So the last lesson for semester 1 is we're talking about linear inequalities. Now we've talked about linear inequalities in one variable where we're solving and graphing on just a number line. Well, we're doing it with two variables, so basically it's going to be slope-intercept form when you solve for y, but we need to figure out, well, what do you do with this inequality rather than an equation? Well, I'm going to tell you, you're still going to get it into slope-intercept form, and the boundary line is still going to be the same as y equals mx plus b. Well, the difference is, we know in the past, like for strictly lesson, we've used open points on the number line when we've graphed. And then if there's a or equal to sign, we use a solid point. Well, it's kind of the same. The y equals mx plus b is going to be the boundary. It's either going to be dotted, which is basically a whole bunch of open points, or solid, which is a whole bunch of solid points. Then you're going to end up shading a half plane. Okay? So the problem is, let's see. I think in this example, I wish they had the equation. But I'm going to come up with it. So we know it looks like, oh boy, that's -6, 4. So it looks like that's -2. So it's going to cross, I'm going to say that the b is -2 on this graph. And then if we do the slope, and this is crossing at +1. So basically, if I go up 2 over 1, the slope is going to be a +1/2. And it looks like it's a solid line. And so it's like when we used our solid point. So I'm going to say this would be the equation y. We know there's an or equal to, but I don't know if, I'll explain less than or greater than in a second. But then the mx plus b, I'm going to put 1/2 x, and then our b is -2. Now, notice, if this is my y-intercept, there's my b. All the, see the shading has the y going to positive infinity? So all the shading for all the y's are going to be greater than the mx plus b. So it's going to be greater than, and because it's a solid point, you put or equal to. Okay? So here, when I ask, well, what is a linear inequality? It's a dotted or solid boundary line and a shaded half plane. And I'll explain how you know the inequality and the y-intercept is going to tell you whether you shade above or below, whether you want y bigger or smaller than the line, depending on the greater than or less than. So it's actually pretty easy. Well, what is the solution? Basically, it's any and every point. Any point that I pick here, anywhere in that shaded area is going to be a solution. So if I plugged in those points to the equation, so like let's say I picked the point -4, 2. If I plug in the point -4, 2 right here to this equation, I'd plug in the 2 for the y, greater than or equal to 1/2 times -4 minus 2, and I want to see if it should give me a true statement. So then here I have 2 is greater than or equal to 1/2 times -4 is -2 minus 2. Well, is it true that 2 is greater than or equal to -4? Yes, that is true. So see, that's why this point is in the shaded area. So what's a solution? It's all points in the shaded region or shaded half plane that make the inequality true when you plug it in, or plug in the x and y values. Okay? So basically, just the opposite. If I plugged in any point that's in the non-shaded area, it would give me a false statement, okay? I'm not going to show you that right now because like over here, you're not always going to have a graph. They may give you the equation. It's basically in standard form, but for an inequality. If they want you to determine, so basically that means yes or no, which ordered pair are solutions to the linear inequality, all we're going to do is plug these in to the equation, or the inequality, and see if we get a true statement. Then yes, it is a solution. If it's something like 5 is greater than -2, which we know is false, then it's not a solution. So let's practice that using this equation. So we have 2 times the x for this point, which is 2, plus, or nope, it's -3, sorry. -3 times the y, which is 5, is less than 15. Now, we don't know if that's true or false yet, so that's why I put a question mark over the inequality. The work is going to tell you. So now we just do order of operations and multiply, so I get 4 minus 15 is less than 15. Well, 4 minus 15 is going to be -11 is less than 15. Well, guess what? That's true. So yes, that is a solution. So in other words, if I was to graph this, this point would be in the shaded area. So, okay, let's try the next point. So we plug it in. We do 2 times the -1 minus 3 times the -7 from the point, and then we copy the less than 15. And again, we're not sure. So 2 times -1 is -2. -3 times -7 is +21 is less than 15. So then -2 plus 21 is 19 is less than 15. Well, guess what? I know 19 is not less than 15, so this is false. And this is not a solution. Okay? Okay, I want you to try these two on your own, and then pause the video and see if you got it correct. Now, let's talk about graphing. It's basically the same steps as graphing y equals mx plus b, except it's not always going to be a solid line. It'll either be a dotted or a solid line. But first step is always the same. You have to write the inequality in slope-intercept form. Okay? That way you can read the m and the b. Just like we've been doing, usually we use open points. Oops. When you've graphed any inequality on a number line with a less than or a greater than, well, open points, a bunch of open points, basically they decided to use a dotted line. Dotted or dashed. I like dash just because that's what they use most, just because it's easier to draw than a bunch of dotted lines. Anyways, because it would be basically a whole bunch of open points. Now, like here, we've always used solid points. Well, if there's an or equal to, you have a bunch of solid points, which makes a solid line, just like you're used to. Now, I'm actually going to say, not use A, I'm going to say use the inequality arrow trick to determine which side of the line to shade. Basically, you want to know, is y bigger or smaller than the mx plus b depending on the inequality. If y is greater than, wherever the y-intercept is, you want the part of the line shaded where the y goes to positive infinity. But let's say it was less than. Then you would want the part of the line shaded where the y goes down to negative infinity. Okay, let me show you what that means. It might seem a little confusing, but when we do some together, it'll be a little clearer. First thing I notice is I know I'm going to use a dashed or dotted line. Okay? Since it's already in slope-intercept form, I know my m is 1/3 and the b is -5. So I'm going to go down to -5, and instead of a solid point, I'm using an open point, right? And then I use my slope, I go up 1 over 3, and I use another open point. So maybe you could say dotted line / open points. And then it's just easier, and again, I just turn my paper, and customarily they just use a dashed line to represent a whole bunch of open points. Now, which way do we shade? So this is like part A and part B for the shading. I want you to look at this. Is y bigger or smaller than the mx plus b? Since y is bigger than the mx plus b, you want to shade the half plane where y goes to positive infinity. What that means is, see this line? It basically separates the graph, which we call a plane, into half planes. This half and this half. It may not seem like a half, but if these go on forever, it would be a half. Well, since y is greater than the mx plus b, guess what? I always put my point on the y-intercept, and isn't this where y goes on forever and ever up to positive infinity? So this is where all the y's are going to be bigger than the line. So I want to shade this part of the graph. So every point that's in that area is, if I plugged it in, it would be correct. Okay. So now let's look at number 2. First thing I would notice, because of the or equal to, we need solid points and line, just like we're used to. Our m is -2, but since we're graphing, we want -2 over 1, and, well, remember the equivalent was +2 over -1, and the b is -1. So here I can go to -1, I can use a solid point because of the or equal to, and my slope tells me to go down to right 1, solid point, and up to left 1, solid point. Now I just basically fill in everything, drawing the line with the solid line. I don't need to do a dash. I only do a dash if there's no or equal to. Okay, part B. Well, what's the correct half plane? We'll see this where y is less than the mx plus b. So if y is smaller than the mx plus b, you want to shade where y goes to -infinity. So see, this is the y-axis. So I kind of put my finger on, this is the y-axis where it goes down to -infinity. So if I put my finger on the y-intercept, isn't this whole part less than the line where all the y's would be smaller than the mx plus b? So that's where we shade. Okay, so the only difference for these, like 3, 4, 5, and 6, is that you have to solve for y first, and then you graph it. Well, one of the universal rules when you're talking about inequalities, the universal rule, is if you divide both sides by a negative number, you flip the inequality. And basically this is review from quarter 1. This rule, no matter what type of problem it is, if there's an inequality, this rule holds true. And you'll know that from here on out through geometry, through algebra 2, pre-calc, calculus, everything. So to solve for y, to get it into slope-intercept form, we start by subtracting the x just like we're used to. And we still have the -2y, so you got to make sure you don't, keep your signs, don't lose your negative. Greater than -5x plus 12. But as soon as I see I have to divide by a negative, I see the negative coefficient, I know I'm going to have to flip the sign. So go ahead and divide it, but just remember when you flip it, you should have y is less than, and then negative divided by negative is +5 over 2x, and +12 divided by -2 is -6. So I know it's dotted or open points or dashed or whatever you want to call it, dotted, dashed. And we know that the m is 5/2 and the b is -6. So I'm going to go down to -6. I'm going to use an open point, and then I'm going to go up 5/2, another open point, and then I'm just going to fill that in with dash line. Just make sure it's really clear that I see the difference between solid lines and dash lines. Now for part B, I just ask, is y bigger or smaller than the mx plus b? Well, because it's less than, y is less than the mx plus b. Well, where does y get less than? It's where y goes to -infinity. So if I put my finger on the y-intercept, the y-axis goes down to -infinity where it's smaller than the line on this whole side, okay? Because even this, if we plug this in, the y would be smaller than the mx plus b. So try 4, 5, and 6 on your own. In fact, do 7 and 8 as well, because these are the special cases with Hoy and Vux. Well, actually, let's do number 7 together real quick, and then you can do 8. Well, number 7, because there's only a y, we know it's a Hoy, which is going to end up being horizontal. Because it's or equal to, just like we did up here, we decide whether it's solid or open points first. Same thing. So this is going to be solid. But since it's horizontal, I go to -4 on the y, solid point, and I draw a horizontal line. Now I still have to shade the correct half plane. Now I just have to decide, well, where is y less than -4? Well, guess what? Since y goes down to -infinity here, going down, I shade everything below that line. And in fact, let's just do number 8 together also, because this is a Vux where I'm just going to show you, instead of up or down, we're going to be doing left and right with the shading. But we still start, so we know it's a Vux because there's only an X, there's no Y. So we know it's a vertical line. We still decide, is it a solid or open point? Well, here it's going to be open or dotted. And since it's a vertical, we go to X is 7. Oops. I have to do an open point. I almost made another mistake. And then I draw a dashed vertical line to show that they're all open points. Now for part B with the shading, I just have to say, okay, well, where is X greater than 7? Well, this time I only care about the X, not the Y. Well, doesn't X go to +infinity to the right? So wouldn't everything to the right of this line be greater? So that's where you shade. So go ahead and do 4, 5, and 6, and then check to see if you have the correct